Now take a look at the sheet that you were given today, the new sheet that you were given today. Some of you were probably even working on that sheet while I was doing this part of the lesson. Okay, this is the new sheet that you should have been given by the substitute when you came in the door. So make sure you have this in front of you. Okay. Problem number 1. Cosine of B equals 0.5. What is the measure of angle B? Well, look, you guys, yesterday I reminded you that if we want to find the angle, we use the inverse trig function. So angle B should equal the inverse cosine of 0.5. So you can put that in your calculator and see what it is. You know what? Let me just go ahead and show you this on the calculator. Inverse cosine of 0.5. So remember, to do inverse cosine, we do second cosine. And then you can do your 0.5. So that is 60 degrees. So that's why the answer number 1 was 60 degrees. Now look at number 2. The lengths of a triangle are given. Determine whether it is 45, 45, 90, 30, 60, 90, or neither. Well, look at A. Notice how it has two sides that are the same. Well, a 45, 45, 90 triangle has that. But the hypotenuse should be 11 radical 2. So that's going to be neither. Look at this one. Again, I have two sides that are the same, like a 45, 45, 90. And this time it does have the radical 2. So this will be a 45, 45, 90 triangle. Look at this one. It looks like this might be a 30, 60, 90 triangle. If so, 6 is the short leg. If we double it, that should give us the hypotenuse. There it is. 12 could be the hypotenuse. If we take that short leg and we multiply by radical 3, that should give us the long leg. And there it is, 6 radical 3. So this is a 30, 60, 90 triangle. Look at this one. This is looking like it might be a 30, 60, 90 triangle. If so, 7 would be the short leg. If we double it, that would give us the hypotenuse. And there it is, 14. If we take this and multiply it by radical 3, that would give us the long leg. But this is wrong. There's a 14 here. If this were the long leg, it would be the short leg times radical 3. It should be 7 radical 3, not 14. So this is going to be neither. And looking at the last one, I see the radical 2, so only the 45, 45, 90 triangle has a chance. But a 45, 45, 90 triangle is always isosceles. So basically this 10 should have been a 5. Then it would have been 45, 45, 90. But as it is neither. Okay, so that's number 2. Let's look at number 3. The ladder is 15 feet long. How high up is the window? Well, ladder's 15 feet. That means 15 feet goes right here, the length of the ladder. How high up is the window? That's going to be this distance right here. I'm going to call it X. Okay, that's the height that we're looking for. Well, look at this 43, and then we've got the x and the 15. Which trig function is this looking like? Let's see, based on the 43, x is opposite and 15 is the hypotenuse. Opposite over hypotenuse, that's the sine function. So sine of 43 should equal x over 15. To go ahead and solve for x, we will multiply both sides by 15. So multiply by 15, multiply by 15. Those cancel out. And if we needed an expression instead of a decimal, this would be the answer right here. But let's go ahead and find a decimal. This should be 15 sine 43, and I'm getting 10.23. It says nearest tenth, so 10.2. Okay, so that would be your answer. This is a picture of a radio tower with a support wire attached to the ground 70 feet from the bottom. So we've got this picture. How tall is the radio tower? Well, that's going to be this length right here. I'll call it x. What trig function am I going to use? Look at the 38, look at the 70, and look at the x. Which trig function is this? Well, from the perspective of the 38, x is opposite and 70 is adjacent. The hypotenuse is here. We have nothing on that. So opposite over adjacent. What function is that? That is the tangent function. So tangent of 38 degrees should equal opposite over adjacent. So x over 70. And again, to get that x by itself, we're just going to multiply. Multiply both sides by 70. So again, if I wanted an expression for an answer, that would be it. If I want a decimal, I will type, I'll show it this time on the calculator, 70 tangent 38. You really just type it in just like it looks. 70 tangent 38. Just like that. You don't even have to close the parentheses. So we get 54.689 to the nearest tenth. That would be 54.7. Okay, so 54.7. How long is the support wire? I'm going to go ahead and call that H, because that is the hypotenuse. So forget about the x for a second. The support wire there is h. This time, still using the 38, we have adjacent and hypotenuse. That's going to be the sine function. No, the cosine function. Cosine of 38. Adjacent over hypotenuse, so that's going to equal 70 over h. What's the quickest way to get h by itself? Remember this? So if we make that swap, we're going to have h is 70 over the cosine of 38. If we wanted an expression for an answer, this would be the answer. Or we could put that in our calculator. 70 over cosine 38. You should be getting 88.8. So that is the answer, number 5. Okay, let's see. Sine of angle M. Sine is opposite over hypotenuse, so that would be 12 over 37. Now look at this, 1 over sine M. I want you to understand that if you put 1 over something, that's the same as the reciprocal. What will be the reciprocal of 12 over 37? Well, sure, that's just going to be 37 over 12. So please, this shows up on the EOCT all the time. 1 over something is just the reciprocal. So cosine of m is here, so adjacent over hypotenuse. So 35 over 37. What will I get if I do 1 over cosine m? That's the reciprocal, 37 over 35. One more, tangent of k. Here's k. Tangent is opposite over adjacent. So looking at k, that's 35 over 12. So of course 1 over tangent k is just going to be the reciprocal, which will be 12 over 35. Keep that in mind. We're definitely going to need that later. Alright, for now let's go on to number 7. What is the angle of elevation? Well, it's shown to be right here, x. So we're basically solving for x right now. 750, that's opposite. 350, that's adjacent. Sounds like the tangent function to me. Tangent of x is equal to opposite over adjacent. That means x is going to equal the inverse tangent of 750 over 350. And that is 64.98. That's going to round to 65.0. Okay? Number 8 is practically the same thing. You lean a 20-foot ladder against the house. And, well, we have everything shown. We're supposed to find the measure of this angle. Let's see, we have adjacent and we have hypotenuse. So that's going to be cosine. So cosine of angle theta is going to equal adjacent over hypotenuse. But we're supposed to find the angle. So of course the angle is going to equal the inverse cosine of 4 over 20. Or I guess we could have put 1/5. So that's going to be 78.5 if we round to the nearest 10. Degrees. Okay, look at problem number 9. Which expression is equivalent to cosine 25? Let's see. Cosine 65. Well, let's play around with this a little bit. If we have a right triangle, okay, first of all, if one angle is 25 degrees, what's going to be the measure of the other angle? The other angle is going to be 65 degrees. Okay, so we have to keep that in mind as we answer this question. So, remember what we talked about earlier in the class? Cosine of one angle will always equal the sine of the other angle. So cosine 25, that should equal the sine of 65. Boom. The answer to that one is going to be B. Now, what about this one? We didn't really talk about ones like number 10 before. Let's see if we can figure it out. Okay, looking through this problem, again, we've got the 25 and the 65. Just like this right triangle, 25 degrees, 65 degrees, they go together in a right triangle. But this time we're dealing with tangent, so we have to be a little bit more careful. So let's take a look more closely. So let's see what we have here. Let's say this is our 25-degree angle and this is our 65-degree angle. Okay? Let's call this X and let's call this Y. Now, we're supposed to find the expression that's equal to the tangent of 25. Am I right? Which expression is equivalent to tangent of 25 degrees? Okay, so tangent of 25 degrees. In terms of our X and Y, tangent of 25, that's going to be opposite over adjacent. So that would equal X over Y. Now, what about tangent of 65? Because I see a lot of 65 degrees among the answers, so let's play around with that. What would be an expression for tangent of 65? Well, opposite over adjacent, that would be Y over X. Are these equal to each other? No, one's X over Y and one is Y over X. They're not equal, but they are closely related. What do we call the relationship between these two fractions? I'm hoping you can see that these are reciprocals of each other. They are reciprocals. So, what would I have to do to this tangent 65 in order to make it be the reciprocal? If I could turn this upside down, it would be equivalent to tangent 25. So I want this to be the reciprocal, X over Y. And just a few minutes ago, we learned something that caused a reciprocal. Do you remember what it was? Well, I'm hoping you remember. In fact, let me just look back really quick. Look at problem number 6. Every time we put 1 over something, all it did was it caused the reciprocal. 1 over cosine m just did the reciprocal of cosine m. So, it seems like if we just put 1 over tangent 65, like this, that will do the reciprocal and have it turn out to be X over Y, just like we want it. So, tangent 25 should be the same thing as 1 over tangent 65. Because we needed the reciprocal, so we had to put a 1 over it. So looking back at this, and there it is. Can you see which one is the answer? Again, it's B. 1 over tangent 65 would be the same thing as tangent 25. That was a little tricky, but I think you can handle it. Now, we're not going to have time to do problem number 12 again, but I think you already know how to do it. But hopefully, let me check the time here. Alright, depending on how long it took to start the video, the bell may be ringing right now. But hopefully, I have time to go ahead and do this problem. If I run out of time, please just go on Edmodo and watch the rest of this video when you get home. Do not leave without the other sheet. There's one more sheet, the second sheet for today. The sub has the other sheet. Do not leave the room without it. Anyway, looking at number 11, which angle has a cosine of 3/5? Okay? Now look, you know what? I really need to make this bigger so we can see what's going on. Okay, I need to know which one has a cosine of 3/5. Now look, this length right here is 6. Can you see it? This length is 6. That means if it's 6 all the way across, that means this is 3. If this is 8 from top to bottom, that means this is 4. So this is 3 and 3, and this is 4 and 4. This is a rhombus, and a long time ago we learned that a rhombus will always make a 90-degree angle at the middle. So these are all right triangles. If we did the Pythagorean theorem, 3 squared plus 4 squared, we're going to find out that the hypotenuse in all of these cases is 5. So I would do the Pythagorean theorem to find out that this is 5. Now, which one of these angles has a cosine of, what was it? 3/5. I'm looking for a cosine of 3/5. Well, let's see. Angle ABC. Angle ABC. Well, that's this big old angle up here. That's not even inside of a right triangle. So it's not ABC. What about DBC? DBC. Okay, I feel like I should change colors. DBC is this angle right here. Now, it doesn't matter that it went all the way down to D. Just look at this triangle right here. This is the triangle you should be focusing on right now. This angle, the cosine, we're talking about cosine, would be adjacent over hypotenuse. So that would be 4/5, not 3/5 that we wanted. So it's not that one. What about BCA? Let's see. BCA. Well, BCA is this angle right here where I just put a theta. Cosine of this angle would be adjacent over hypotenuse. BCA. That's this angle. Adjacent over hypotenuse, well, that's going to be 3/5. That's why the answer to this one is going to be C. Okay? Do not leave without the other sheet. Part 4 of 4. But I'm going to go ahead and do this problem even though you will only see it if it's on Edmodo, because we're definitely out of time by now. Look at this one. See how the angle is down here? For that reason, I'm going to make my 90-degree angle right here. This 20 is an x value, so that means it will be 20 horizontally like this. This p is the y value. That means p is going to be vertical like this. That means if I do the tangent function, tangent is opposite over adjacent. So that means this tangent function should equal p over 20. And then we will cross multiply. So 4p should equal 60. Then if I divide both sides by 4, I get p is equal to 15. And that's the answer. And that's going to be the end of this video. If I get a chance, I will make another video for the part 4, the paper that you're getting right now, or the paper that you just got. So the part 4 of 4. Check Edmodo tonight if you're having trouble, and if you're lucky, there'll be a video there. No promises, but watch for it.